Good afternoon, everyone. Thank you for joining us. We are proud to present our next speaker, Krithika Balaguranathan, with TIBCO Software. Please give him a warm welcome.
Hey, end of the day, hopefully this is exciting. I see some ideas. Come talk to us at the end of the session or at the booth. Yep. So I work as a product manager at TIBCO. Among other things, I'm more focused on event processing and decision management, much of which I'll cover today. So decision management is an interesting topic. All of us make decisions on a daily basis, personal and otherwise. Technology may help with the personal decisions, but really we're focused on the simpler problems when it comes to running your businesses more efficiently, right? So you're surrounded by data, look around you, there's like tons of information going through your systems, your sensors, partners, all the interactions that you have with customers. But are you able to derive the right value from all these data points that are flowing through the system? I'm sure many of you probably are using some of the services within Amazon or outside, including Apache Kafka, which is prevalent on almost every application that's been built by developers today. But really the focus is how do you convert the data that you're getting in to offer more immersive experiences when you're trying to interact with your customer, or really in a supply chain operation scenario, are you able to offer more seamless operations? So this is all the focus of decision management techniques, right? And being able to quickly respond to market changes. So real quick, I mean, why it's important, around 80% of the survey respondents on a recent HBR survey focused on how building more intelligent automation into business processes is important to the success of the enterprise. And clearly, all organizations have some app which does decision management or trying to determine what's next best course of action. Typically, this is where you store data, you apply some analytical processes, and then you decide what needs to be done. In a lot of cases, doing it after the fact is great, but in a lot of situations where you're detecting fraud or trying to engage with your customer while they're shopping, these after-the-fact decisions are just not going to be sufficient. And again, going back to why this is more important, as you can see, the value of data and event incrementally decreases over time. And being able to capture it in real time and to determine what's the right course of action or the decision you want to take to offer a more meaningful experience to your customer is really important when it comes to efficient decision management techniques. And in order to do that, the way applications are built need to change from being more deterministic, where you know every app needs to go through a sequence of steps to determine what the next best course of action is, to being more smarter, be more adaptive, looking at machine learning, predictive and prescriptive models to decide what needs to happen best. And machine learning is the answer, of course, but not the only answer. In a lot of cases, event processing is good enough where you have sample patterns that you can detect. This could be processing of streams, or a mode we're using declarative rules, where it is if-then conditional blocks, where you're looking at certain conditions to be evaluated and what needs to happen as a course of that. And machine learning further augments the decisions that you make with the ability to classify these large data sets and look at patterns and apply a broader range of data points to determine and basically combine these two to make your decision management techniques much more efficient. And it comes into the product that we offer. TIBCO, for some of you who probably are familiar with it, it started off as a messaging company, and we've expanded from there on to really connect with the developers. And this was the first attempt to directly connect with our developer ecosystem with Project Flogo. And it's 100% open source, and I'll get into what all it offers. It offers a broad range of capabilities, hence it's an ecosystem in its own. And it's 10 to 50 times lighter compared to any other Java or .NET or Node.js application that you'd build. The reason is that it's built on Golang, hence the name Flogo, right? It's a common core for event-driven applications. I think every app that your developers are trying to build is event-driven in nature. So being able to deploy all of this into any of your cloud compute services, including serverless, is sort of the foundation of what Flogo is. And more recently, we've done a lot of work in terms of what we enable in the machine learning aspects in order to make the decisions that you make much more smarter. So basically, I mean, since it's 20 minutes, it's too little time to go into too many details. I'm just going to get into overall what it does, right? It's got a simple constructs where an app is equal to a trigger and an action. So trigger is how your data comes in. Could be a Kinesis or MSK or Kafka. And basically, the handlers look at how do you want to dispatch these events. And actions, no surprises there, is what you want to do with the event as a result of the processing. Right? So it's pretty simple. We've got a broad range of capabilities within the ecosystem, right from the ability to build flow-based integration flows, so connecting systems to people, connecting B2B systems, B2C, all of those. It also has a stream processing capability. And the stream processing by no means is to disrupt the stream processing vendors that are already established out there, but it's simple and lightweight enough for your basic stream operations, especially when you're trying to pre-process data prior to executing your machine learning models. And the more recent addition is the contextual rules, and I'll talk about it in a little more detail when I get into that. So the core, as you can see, is all about event-driven and being able to internally channelize the changing, bundle all of these application needs into a single binary, right? And it's a common contribution model, so you're able to use any of the 100+ activities and triggers to just about extend to what you want to do. And it has simple inferencing capabilities, and you can extend to do what you want depending on the type of the application that you're building to handle your decision management. So another way you want to look at triggers is streams, right? So what this provides is a much more lightweight stream processing capability, which you can even deploy to the edge. So it offers a lot of core stream capabilities, including aggregations, being able to join streams. It could be an MQTT with a Kafka or any other trigger for that matter. And being able to filter out the noise, especially when you're trying to execute a machine learning model, much of this comes into play, and it's very handy and efficient for you to do that. So a little more about the capabilities that are part of the streams is being able to clearly doing joins, aggregate and filter, and basically feed it to an inferencing model for further processing. And yeah, the aggregations, like I said, really simple, what you'd typically use in a lightweight scenario, tumbling windows, sliding windows, a bunch of different things that you can do here. And the other interesting part of this whole ecosystem is the rules capability. It's a declarative contextual rules engine. So the declarative part is implicit because the rules engine by itself is declarative. And what I mean by declarative is, in a lot of application processing techniques, you always, or the application developer knows the sequence of steps that every transaction needs to execute in order to come to a final conclusion or an action. But what rules does is it gives you the ability to just define if-then condition blocks. The rules engine handles the sequencing of the rules itself behind the scenes. So you're more concerned about the logic as against to tying the bits together in order to execute an application logic. And what I mean by contextual is being able to keep the state. For instance, say a flight is sending out an event that a door is open. You need to really know what is the context for the flight open event that you've gotten. Is it open flight? Is the door open mid-flight, or is it open for customers to board, or is it open for customers to deboard? So all of this is what I mean by context, where you need to know what happened before. Is there any related data points that I need to look at to arrive at the right possible decision? So all of this, again, part of the whole core open source ecosystem, lets you build these declarative rules for more contextual, state-aware decisions. And for the exciting part, which is machine learning, Right now, what we offer is the ability to execute TensorFlow models. It's, again, 100% open source. And once we launched this, the more interactions we started happening with data scientists, the problem seemed to be much in the fact that data processing, data prep, took about 80% of the time and effort. And production has to essentially replicate all of this, right? So clearly, everyone gets different data sets to start with. And how do we make this process of data cleansing and data prep much more efficient, right? We wanted to look at other options that are out there for pre and post data processing. And we found this was a largely unaddressed problem. And that really resulted in what we called Catalyst ML, which is a language-agnostic way for defining data transformations. So you're able to use 85+ mathematical models, and it maps directly one-to-one to your machine learning models. And you'll hear more about this on a session tomorrow. It's much longer, so it'll go into a lot more details. It's pretty cool because it has like an open JSON spec that you can map, or you can use to convert and map. So these capabilities are available on AWS. Clearly, you're at an AWS conference as a service, of course, as an open source offering. You can talk to us if you don't want to get onto a commercial NDA and all of those different things. You can get onto the open source GitHub repo. We're pretty active on the Gitter as well, so you can talk to our developers one-on-one. And with that, I'll quickly get into a demo of how this works. I'm hoping, yeah, there you go. So just to give you an idea of how the app building construct looks. Of course, if you don't want to do any of this, you can write your application logic in native Golang. But if you want to use the web UI to speed up your time to market, yeah, this is a quicker way for you to do that. So as you can see, this is a simple fraud detection example. You can use the stream processing to aggregate some of the data streams that's coming in and use Catalyst ML to pre-process, map, and execute the inference ML model. And you're able to run the simulator to look at the data going in and the result of the evaluation. So real quick and simple. Again, got a whole bunch of capabilities we've been extending based on the interest that we've been getting from developers like yourselves. So yeah, that's a quick demo, I guess. Yeah. Any questions? Go ahead. Oh. Sorry, I got yeah. Okay, there you go.
Why wouldn't you start out with something like NIME and build on top of that?
Well, do you want to handle that? It's comparison to NIME. Well, it has some of these capabilities that's already there, but I think the data prep, some of those are not addressed. Like I said, we aren't trying to solve the problem of ML across the board. What we do is the ability to execute TensorFlow models. And as you can see, there's an app building construct for building an app and executing an ML model, but not really authoring. NIME is more for data modeling. Yeah. So this, even the Catalyst ML part is dealing with the transformation of data as against to, giving you an app flow to do that.
Any other questions?
All right. Thank you.
Thank you so much. Please come back and join us for our final presentation of the day at 5:40. Have a great show, everyone.